All right, hello once again, pre-calculus people. So we're continuing the series now on exponential and logarithmic equations. Last video we talked about how to solve exponential equations, and today we're going to talk about how to solve logarithmic equations. The steps are shockingly similar. We're still going to get the log or the ln term by itself. Once it's by itself, we're going to undo that. The verb for that, here's your new word of the day. It's called exponentiating. But you really just turn both sides into an exponential. And then just like yesterday, the log and the exponential will kind of cancel each other out. And we continue solving for x. There's a couple of kind of special cases where we have to use some log properties, but we'll get to those examples in just a minute. So let's go and jump on in here. So first example, again, when we want to isolate, right? So we're looking for that log piece to get by itself. So how do we do that? So we're going to subtract 5 first, and then we'll divide by 3. So if we subtract 5 from both sides, we have 3 ln x equals 4, and then divide by 3 on both sides. So we'll have ln x equals 4/3. Okay, now here, and again, here's this new word of the day, exponentiate. Really what this means is you take whatever the base is, and for these, a lot of times we're just going to use ln. So the base, if you remember from the definition, the base is e, Euler's number. So we're going to raise both sides to the e power. So the way that would be written would be e to the ln x equals e to the 4/3. It's a process of exponentiating. So what happens, again, just like yesterday, the e and the ln cancel out, so you're just left with x, and that is our exact answer in this case, is x is already by itself. So we have x is equal to e to the 4/3 power. And again, as I said yesterday also in the last video, I don't really care about the calculator answer. We'll do that later on when we get into the application problems. So this is our exact answer, and we're good to go. Let's take a look at the next example. So again, the first bit is to get ln by itself, and then just kind of keep on going from there. So in this case, we're going to add 3 to both sides and then multiply by 2. So we got 1/2 ln of 5x equals 4, and then multiply by 2, so ln of 5x would be equal to 8. Exponentiate both sides. It's going to look like this. And then again, same thing happens every time. The e and the ln's basically cancel out, so you're left with 5x equals e to the 8th. In this case, we got one more step to do. So we divide by 5. And so we have x is equal to e to the 8th divided by 5. And now remember that the domain of the log function is all real numbers. But we do have to make sure, and not so much on these problems, but when you get to a couple of them on the back, we're going to see a couple where you're going to have to check the domain. But in these cases, we're all good. And it won't be a problem. Okay, and again, exact answer, not worried about the calculator answer until we get into some application problems. So just to recap, we're isolating the ln, exponentiating both sides, and then just continue solving for x, doing the algebra thing. So I got one more example for you to do on your, by yourself. So if you want to pause the video and take a look at that example, and then I'll zip through the answer, and then we'll do one more where we have to deal with some log properties, and then we'll wrap it up. All right, so again, isolating the log function, so subtract 7, divide by 3. So we're going to have 3 ln of 2x plus 1 equals 6, and then divide by 3 is equal to 2. Exponentiate both sides. And then we have 2x plus 1 equals e squared. And then again, just continue solving for x. Be a little careful on how you write the final answer. So when I subtract 1, I'll have this. And when I divide by 2, I can write my final answer as e squared minus 1 all over 2 would be fine. Exact answer, Dunzo. So the last example I have for you is something like this. So again, something here, I can't isolate the log anymore because not only do we have things on both sides, but the arguments are different. There's all kinds of stuff going on here. Okay, but what I can do is use what we did in an earlier video on condensing and expanding log expressions. And notice on the left-hand side here, I can combine these with the product rule. So really what this ends up being is the ln of x minus 2 and 2x minus 3. I don't need to worry about the right-hand side yet. I'll get to him in a minute. But notice on the inside, I can multiply those binomials, FOIL, box method, whatever you want to, whatever makes you happy. So I have this. So I have the ln of 2x squared minus 3x minus 4x, that's minus 7x, and then plus 6. Okay, and then, I didn't write the squared, sorry, 2x squared. And then remember, that's still equal to this, but also notice in here, I'm going to deal with the right-hand side. Notice 2 ln x, I can use the power rule, and I can write that as ln of x squared. So if I rewrite the equation now using what I did with the rules, I have this. I have ln of 2x squared minus 7x plus 6 equals ln of x squared. Well, listen, you can exponentiate both sides, but really, if you think about it, I have the ln of something equals the ln of something, so I can set the somethings equal to each other. Okay, so I can just write 2x squared minus 7x plus 6 equals x squared. Keep on forgetting to write squared there, sorry. And then I can subtract x squared from both sides just to combine some like terms. I have x squared minus 7x plus 6. And oh, look, I can factor that. Negative 6 and negative 1 equals 0. So my solutions, to set both of those equal to 0, are 6 and 1. Okay, now here's the catch. On these questions, it is really, really important that we take these solutions and go back to the original function and make sure that they are in the domain. Because remember, the domain of the argument of a log function has to be greater than 0. Okay, so if I plug in 6 to the first one, 6 minus 2 is 4, it's okay. If I plug it into the second one, 2 times 6 is 12 minus 3, it's okay. And I'll plug it into the last one, got to do all of them. 6, obviously that's greater than 0 too, so that one checks out, that's a good solution. If we do the same thing for 1, notice on this first one, if I plug in 1, 1 minus 2 is negative 1. That is not okay. So this is what we call an extraneous solution because it is not in the domain of the function. Okay, so your only solution is x equals 6. X equals 1 is what we call extraneous, so it only has the one solution. Okay, so really what this would mean, if you were to graph this problem, it would only intersect in one point. So even though algebraically we got 2 solutions, there's really only one solution. So it's really important on these factoring type questions that you check the domain and check for extraneous solutions. So that is how you solve log equations. If you have questions as always, you can come in for tutoring, ask for some help during class. Until next time, stay safe.